Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of August 5th this time around. Those of you who've been watching these little shorts for a while know that we like to start each week thinking about what the moon's doing, because the moon affects so much about what we can see or can't see. And this week, the moon starts very close to new and ends just short of first quarter, about 45% full. So it's waxing and filling out and rising later and later and later as the week goes on. As it does that, on the evening of the 7th and the morning of the 8th, really the evening of the 7th, because it's such a slender crescent moon. It's a beautiful slender crescent moon, so it's worth checking that out. It's near the star Zavijava in Virgo. And so this is going to be a pretty moon near a nice star. 2 nights later, on the 9th into the 10th, the moon's about 25% full. Still an evening object. Still the evening of the 9th is really when you want to check this out. And it's near the bright star Spica in Virgo. So we've got the moon making a few interesting pairings. What this means is the moon will be up in the evening, not so much in the morning. In the morning, if we think about the morning of the evening of the 11th into the morning of the 12th, so rising at about 1:30 in the morning, on the morning of the 12th, Mars and Jupiter. Remember, we've been tracking Mars closing in on Jupiter, closing in on Jupiter, closing in on Jupiter for a long time now, and it's almost there. They are less than a degree apart. So you've got big, bright Jupiter and red Mars right there, just right on top of each other. You hold your finger out at arm's length, that's a degree. These things are less than that degree apart. So they're right on top of each other and still closing a little bit. So we'll talk about it again next week. It's going to be great. But this whole week, you watch that gap just shrink right down. So if you're not there in that morning, that's okay. If you've got clouds or you're not up that morning to be able to see it, you can see it happening as Mars closes, and it'll be nearby. The two will be very near each other for the next week as well. And so you got time to look at that. But on the morning of the 12th, it's probably your best shot to catch the Perseid meteor shower. So you get out there to check this out. The moon will have set. If you're out on the morning of the 11th or the morning of the 12th or the morning of the 13th, they probably all work. Remember, this is one of the best meteor showers we have, the most reliable meteor showers we have. We hit it this time each year. We go through the debris trail left by a comet, stuff that gets boiled off a comet when it's near the sun. And that debris trail isn't microscopic. It's a big tunnel of material, so it takes us some time to pass through it. So you've been able to see Perseids for a little while. You can see Perseids all week. So go out and you'll be able to see a little bit of enhancement in the background rate of meteors. And all of these meteors will be coming from the same point of the sky in Perseus. But the peak should be somewhere around the morning of the 12th. Probably daylight for those of us in North America if the forecasts are accurate. But that morning before that it gets light is a great time to see it. So this is if you pick one thing to do this week, this is probably the thing I would do, is get up on the morning of the 12th, the night of the 11th, and see Jupiter and Mars really close together and watch some Perseid meteors. And I think that's going to be a great astronomical week for you, just those things. But the moon's going to be nice getting there, and you can watch Mars closing that gap as the week heads on, and you can see some Perseid meteors. So you got this whole thing leading into it. Now, in the evening sky, when you go out as soon as it gets dark, for me, Vega is this bright star that's at the zenith, directly overhead. I live about 43 degrees north latitude, so that puts Vega right overhead for me, depending on where you are relative to that declination, that latitude. You'll see Vega south or north of the point directly overhead. Deneb will follow that directly overhead a little bit later. So Deneb and Vega are the two bright stars that are right up high overhead. They're two stars of the summer triangle. Altair is down here. We didn't draw it on the board, but Altair is down here to the south, making the summer triangle. And the reason we didn't draw it on the board is because we're going to talk about Cepheus. And to say we like to talk about the moon, we like to talk about the planets, but now let's talk about something we can see and take advantage of the relatively dark skies of the waxing moon here. So if we go Vega to Deneb, make a right angle, and move up a smaller distance than the distance between Vega and Deneb, you come across Aldebaran, and it's a star that's about 2.5 magnitude. So these stars are big and bright. These are among the brightest stars in the sky. So this star is faint by comparison, but 2.5 magnitude isn't faint. So it's a star that's it's relatively easy to see. and it's the bottom star. It's the star in the base of Cepheus. I like to think of Cepheus as a house sort of shape. There's a point here and a point on up here to make this house. But we're going to look at the bottom, the base of that house right there. It makes with Zeta, which is, we've just expanded this region down here. Zeta is a 3.4 magnitude star. So the star on the left, the star to the east there is, as you're looking to the north, the star is the Zeta star is a little bit fainter. Now Aldebaran is derived from Arabic. We say this all the time. Al is the, translates to English as the from Arabic. And this would be from Aldera al-Yamin, which would be the right arm, is the way that would translate into English. And so we've got these two stars. And if we go to Zeta, we like to hop up here to Zeta, the star that's just up here like this, as we've drawn it right here. And there's two stars relatively nearby. Epsilon is a 4.2 magnitude star that sits just below Zeta, and just above Zeta and off there is Delta. And Delta Cephei is among the most important stars in the sky. Cepheid variable stars. If you just can't get enough of me talking, I have from my lab book that I've written for astronomy labs. There's a measuring distances to stars using Cepheid variable stars. So Cepheid variable stars get brighter and dimmer, like that, and the period from brightest to brightest for Delta Cephei. Delta Cephei is the prototype star. That's why they're called Cepheid variable stars. And it has a 5.4 day period. So if you can watch for 5 or 6 consecutive days, you could see this star get about a factor of 2 fainter and get up to a factor of 2 brighter. Depends on when you start, right? It might go from faint to brighter. It might be right in the middle of those two. But anyway, you can see this go from faint to bright and get about 2 times brighter. And it's relatively easy to measure. This is a great observing project. If you've got a stretch of clear nights coming up high overhead right now, you've got any time during the night and see this. Zeta is about 3.4 magnitude, we said, and epsilon that's down here is about 4.2 magnitude. So Delta won't get quite as bright as Zeta, but it will approach it at its brightest, and it'll be slightly dimmer than Epsilon, very slightly dimmer than Epsilon at its faintest. And so you can watch Delta and see how it changes. Just make sketches of it, take pictures of it, do what you want to do, but you can watch Delta very nearby here. This is just a couple of degrees that we're talking about as it goes from sort of Zeta brightness to Epsilon brightness, and you can use those as comparison stars to watch Delta get brighter and dimmer. Great project. The reason these stars are so important is because the time it takes to go from brightest to brightest or dimmest to dimmest, the period, is directly related. It tells you how intrinsically bright the star is. And if you know how intrinsically bright the star is and you know how bright it appears, you can tell how far away it is. So this became one of the most important distance measuring techniques in the universe for us. It allows us to get past the local system to measure distances. For example, it was a star like this, not exactly this star, a Cepheid variable star, but a related star that Hubble used to measure the distance of the Andromeda Galaxy and helped us place the Andromeda Galaxy outside the Milky Way galaxy and let us start to think how big the universe really was. And it was, again, stars like Cepheid variable stars that Harlow Shapley used to measure the distance to the center of the galaxy to get a sense of how big our galaxy is. And so basically it opens up the size scale of the universe. It really opens up the universe for us as we do that. One last object while we're thinking about this. If you go back to the alpha star, Aldebaran is the alpha star in Cepheus, and you drop 6 degrees down from there to sort of the south, you've got NGC 6939, and it is an open star cluster. And we like to look at these open star clusters and have Messier numbers, M, because they're big and bright. But this is a really good one that Messier didn't have in his list, NGC 6939. 100 or 200 stars in there, big, bright, beautiful stars. So worth checking out. You can probably see it with your binoculars. If you have a small telescope, it's great. You'll pass Eta Cephei on the way, a 3.4 magnitude star. And so Eta, so about the same as Zeta over here, and it's closer to NGC 69. So you drop down to the next brightest star, and then another 2 degrees on down, and you get to NGC 6939. So check out that open star cluster. A lot of people out there looking at the Messier objects. So, this is something that not everybody's taken their small telescope or their binoculars and gone to look at. But also check out Delta Cephei, and as it gets brighter and dimmer, and think about our distance measuring in the universe. Don't miss the Perseid meteors. The best night's probably the morning of the 12th, and Mars closing in on Jupiter, and we'll have more of that next week. So this is what we got for you this week. Should be a good week. Hope you have a great week of observing out there, and as always, thanks for watching.